Now let's solve one more question. Now in this question, check the points where the constant function f of x equal to k is continuous. And now if you look carefully at this function f of x which is equal to k, you can see for all real number x, the value of f of x is equal to k. That means if we have a real number c, that means the value of the function at the point c is equal to k. Now let's find out the limit of this function at the point c. Now the limit of this function when x approaches c, f of x is equal to, now when x approaches c, then the value of the function is equal to k. So now this limit becomes limit x approaches c of k, and of course that is equal to k. So that means the limit of this function as well as the value of the function at the point c are both equal to k. And from the first theorem, if the value of the function and the limit of the function at the given point are equal, then that means the given function is continuous at that point. And now, as c can be any point in the real number, that means the given function f of x equal to k is a continuous function. Let's do one more example. Is the function defined by f of x equal to modulus of x a continuous function? Now, as per the definition of modulus function, the function modulus function f of x can be also written as f of x is equal to minus x, where x is less than 0, and f of x is equal to x, where x is greater than or equal to 0. And if you remember, in the earlier episode, you learned that the modulus function is continuous at x equal to 0. And now we shall prove that the modulus function is continuous at all points in its domain, or for all values of real numbers. Now suppose c be a real number such that c is less than 0. Now if c is less than 0, then what will be the value of f of c? Now as per the definition of modulus function, if x is less than 0, then f of x is equal to minus x. And if c is less than 0, then in that case f of c is equal to minus c. And now what will be the limit of the function when x approaches c? Now limit x approaches c, f of x is equal to limit x approaches c minus c, and which is equal to minus c. That means limit of the function at the point c when c is a negative number is equal to minus c, and is also equal to the value of the function at f equal to c. And now let's check the limit of the function when x approaches c. Now if c is greater than 0, then in that case the value of f of c is equal to, now f of x is equal to x when x is greater than or equal to 0. So that means if c is greater than 0, then in that case f of c is equal to c. So now the value of the function at point c is equal to c. And now let's find out the limit of this function when x approaches c, f of x, and which is equal to limit x approaches c, x equal to c. And now because c is a positive number, and for positive number the value of the function f of x is equal to itself. Now if c is a positive number or c is greater than 0, then in that case the limit of the function at point C is equal to the value of the function at the point C. So now we have proved that if C is less than 0, then the value of the function is equal to the limit of the function at the point C, and also if C is greater than 0, then again the value of the function f of C is equal to the limit of the function at point C. And in the previous episode we already proved that if x is equal to 0, then in that case the function f of x, which is equal to modulus of x, is a continuous function. So which means the function f of x is continuous whether the value of x is less than 0 or c is greater than 0, and also if x is equal to 0, then still the function f of x is a continuous function. And because the function f of x is continuous for all values of x, so that means the function f of x equal to modulus x is a continuous function. Now let's solve one more question. Discuss the continuity of the function f given by f of x is equal to x cube plus x square minus 1. Now the function f of x is equal to x cube plus x square minus 1. So each term you can see x cube, x square and 1. Now if x is a real number, then each term x cube or x square and 1, then x cube and x square will also be real number. So that means the function f is defined for every real number c. And what will be the value of f of x at the point C? The value of f of x at point C is equal to f of c, and that is equal to c cube plus c square minus 1. And now let's find out the limit of this function at the point C. Now limit x approaches c, f of x is equal to limit x approaches c, x cube plus x square minus 1, and which is equal to, now when x approaches c, then x cube approaches c cube and x square also approaches c, and 1 is a constant. So the value of the limit is finally equal to c cube plus c square minus 1. So that means the value of the function and the limit of the function at the point C are both equal, and that is the required condition for a function to be continuous. That means the function f given by f of x equal to x cube plus x square minus 1 is a continuous function.